Okay, this one is a little bit tricky. It's from Mathematics for Calculus, I think 7th edition. All right. So now here you will see that we have cos x and then we have sine x in the same equation. So this is two different functions, two different variables. So we can't really solve as this. So we need to make sure that we reduce it to one variable. Now, how do we do this? We can do this by looking at this identity. And that's why identities were very important to understand. We can introduce this identity, but introducing it at this point means that we need to do something like this. Okay. 1 minus cos squared x. If we do that, remember here it's going to be plus and there it's going to be minus. So if I introduce it here, I need to maintain these, meaning that I need to solve it first with that, then secondly with a negative in front here. That can get a bit complicated. Okay, so it's better that we just go on instead and square. It will silently introduce other solutions, but it's cleaner. Okay, so here I'll square and there I'll square. So this one will give me cos squared x plus 2 cos x plus 1 equal to sine squared x. We reach another hurdle here because if I simply went and replaced, let's say if I replace cosine here, okay, with sine squared x, it means that I'll have sine there, but I still have cos x here. So I still have the three variables that I don't want to have. Okay, so I need to replace the sine instead. So replacing sine means that I need this sine squared x is equal to 1 minus cos squared x. So here I'll maintain what I have here. So it will be cos squared x plus 2 cos x plus 1 equal to, now I can introduce this, which is 1 minus cos squared x. Now you see that this can go the other side, it will become positive. So I'll have 2 cos squared x, right? Then I'll maintain my 2 cos x here. But this is positive. So once it crosses here, it becomes negative, meaning that this and that cancels. So my equation becomes this. I can still reduce it because I have the same coefficient here and there. I can reduce this by dividing by 2 throughout. So I have 2 cos squared x plus cos x, like this, is equal to 1, or is equal to 0, is equal to 0. Okay? Thinking far ahead. All right. So this now I can simplify by factorizing. Like we've always said, mathematics is mostly just simplification. If you can simplify a number of concepts, you'll become comfortable with a lot. Okay, so this is cos x, and then that's cos x plus 1. So we can say that cos x is equal to 0, and then cos x, this one is equal to 0, meaning that it will be equal to minus 1. So those are the two values for cos x. Okay. So now we need to remember our the values of the special angles. Okay. So what value of x gives us 0? What value of x gives us minus 1? Right. So we need to remember, we check there are 3 things to check. Normally it's the special angles. Then 2, you calculate the reference angle, which we'll get here. Then 3, you use your reference angle now to calculate, you use your ASTC to get all your angles. Okay. So now let's continue and work out the angles. So for cos x is equal to 0. Okay. We are going to get, if you check the special angles, it will give us x is equal to 90. Okay. At 90, cos x is equal to 0. So we're going to have 90, which is pi over 2. Okay. Then if we have pi over 2, what other angle can we have? Since this is 0, we can have 3 pi, which is 270, over 2 like that. Okay. 3 pi over 2. It will give us 270. Right. Then another one that we can have is that we can obtain it from this one here. So at which point is cos minus 1? Okay. it is at 180 degrees. So here we'll have pi like that. So we'd have obtained all our answers. Okay. So we can say it's 0 if we want. Pi, it's pi over 2, 3 pi, 3 pi over 2, and then pi. But then remember we had squared here. So we could have introduced wrong answers there. So let's check for correctness. Okay, let's check for correctness. So we'll start with cos. Okay, so you just replace these values. Cos. So our original equation was like that, is equal to sine pi over 2, which is 90. So cos 90 is 0 plus 1 is equal to 1. So we'll say that this is okay. Okay. Then we can go and check cos 3 pi over 2, okay, is equal to, or plus 1 is equal to sine 3 pi over 2. Now, if we check our ASTC, okay, we'll see that this is O, this is sine, this is tangent, and then this is cosine. Right. So if we check this cosine 3 pi over 2, this will give us 0. This will give us 1. But sine 3 pi over 2 will be this side, meaning that it will be negative 1. Okay. Now, can positive 1 be equal to negative 1? No. So this will not be part of our solution. Let's check 90. We checked 180. So we check cos 180 plus 1. I'm interchanging because I know what pi is. Okay. I can put pi here. If we want to see that, I can put pi. But it's the same thing. Okay. It's the same thing. Right. So here we can have pi if we want. Right. So cos pi gives us negative 1. Then what is, this is 1. Then sine 180 or sine pi gives us 0. So this is 0 is equal to 0. So this is part of the solutions. So our final answer, therefore, is going to be x is equal to pi over 2 and then pi. That is within this range. Okay. So that's what we have here. Right. So this is how you solve questions like this.